thanks everyone for your time. Thanks for joining. Really appreciate you attending the webinar this evening or this afternoon or this morning, wherever you are dialing in from. Simon Whelan's my name. I'm joined by Cesar from Autodesk and Daniel Stein from Lake Flato. They're going to introduce themselves in a minute, but we're going to walk through just a webinar on optimizing your building envelope design and workflows from Forma to Revit using FenestraPro. We'll be talking about Forma, we'll be talking about FenestraPro, we'll be talking about Revit, and we'll be talking about, Dan's experience, I suppose, in industry as a designer and a digital design director. Just to give a quick intro to myself, I'm one of the founders of FenestraPro. I'm based in Ireland. FenestraPro are based in Ireland. We develop facade design applications, really for, as I said, for Autodesk platforms, Revit and Forma, particularly. We're Autodesk ADN, Autodesk Development Network members. We're AEC industry partners, sustainability tech partners, a whole host of partnerships there with Autodesk particularly. And I suppose my experience with FenestraPro came from a number of years in practice at an architectural firm and starting to specialize in environmental design and, around facades, etc., and the impacts on the building energy performance. Hand over to you, Dan, and you can just give a quick overview to yourself.
Thanks, Simon. Hi, everyone. I'm Dan Stein. I'm the Director of Design Technology. I lead the research program, and I'm also part of the design performance group at Lake Flato Architects, an award-winning, top-ranked architecture firm in the U.S. In 2019, Architect Magazine ranked us the #1 architecture firm in the U.S. I teach graduate architecture students at university. I've written several textbooks, including the #1 Revit textbook in North America. I'm on the AIA National Committee on the Environment Leadership Group. And as part of that, I co-authored recently some updates to the section Architects Are Environmentally Responsible within the AIA Public Policy and Position Statement. And then finally, the US version of IES, not the European version of IES. I'm the chair of the Illuminating Engineering Society BIM Standards Committee. That's it for me.
Cesar, do you want to give a quick... Oops, there you are.
Hi, everyone. My name is Cesar Escalante, I'm Technical Marketing Manager for Autodesk, focused on the architectural portfolio of products. My role at Autodesk is to be a spokesman of innovation that's coming out of our production pipeline and aligning with the way the industry works. I come from industry. I was a practitioner architect for 20 years before switching to Autodesk in big, large corporate architectural practice. I'm also active member of the AIA at a local and national level. And I am also an educator. I teach BIM and BIM related courses at California College of the Art and at Stanford University. Glad to be here.
Cool. Well, maybe we could start with you, Cesar, in a second, just to give a quick overview on Autodesk, what you guys are doing with Forma at the moment. We'll jump back to me then, and we can talk about, Forma and using it for your envelope analysis, envelope design, etc., and bringing that kind of information from Forma to Revit. Dan then is going to just give us a little bit of an overview to a project and how those little guys in Lake Flato used Forma, and talk a little bit about facades and how they impact the building performance. And we'll just kind of touch on some of these kind of key benefits as we go. So Cesar, you take it away there.
All right. Simon, maybe I'll ask you to move forward, if that's okay.
Sure, it seems to be working okay for you there. I'm not touching it, so but
okay.
Yeah, feel free to let me know what you need.
Okay. So yeah, I'll give you a quick overview what Forma is and what the main capabilities are. Forma, it's our latest offering that's focused on the front end schematic design. So imagine you as a designer, you start with a blank canvas, and that's the start of any new project, right? But the truth is that we need to make a lot of early calls early in the design process. And these are decisions that shape how we how our building is going to perform. And sometimes making a lot of those calls without a lot of information, it's a challenge. So during early stage planning, when the design is fluid and architects can make choice quickly, that is when we really need the data to support key project decisions. And these decisions have lasting consequences in the detailed design and construction, and even into operations of the building. See next slide. So the stakes are really high. According to Skanska, more than 50% of residential project value can be realized in early stage design phase. Key decisions made at this point, such as massing and layout, have lasting consequences. And as the design progresses into later phases of the design, those fundamental design choices become very difficult to change without a lot of cost associated with that. That's basically one of the premises of BIM. And so in pre-design, architects and planners need to navigate a large collection of constraints and complexities for a full project. These constraints come from everywhere: owner and client needs, zoning and ruling restrictions and regulations, environmental considerations, financial elements, and a lot of aesthetic criteria, including things like what are the cultural constraints, historic preservation, neighborhood constraint, etc. So evaluating this trade of multi-dimensional variables in a pre-design timeline it's done a lot by architects' intuition and experience, and a lot is done by simple trial and error. Sometimes the answer to the equation is not as simple, and the lack of information at the front end really it's a risk in when configuring the right solution. So the problem is that current workflows in pre-design are limit the full potential of what a project could be. So a better pre-design process is one that help us overcome these challenges. The lack of feedback, for example, a lot of designers operate with limited data, leading to poor informed design decisions during the early stage design. Discontinuity, when you're exploring pre-design, converts on desktop files create versioning headaches, and this results in a lot of wasteful data loss. In the context of collaboration, siloed workflows, it's a challenge. It can lead to lack of consensus across different stakeholders about what's the best direction for a project. And then inefficiencies are also created, limited automation in place, a lot of manual effort, limited our ability to apply creativity and creative solution. So Autodesk Forma, it's a cloud service that offers a powerful AI-powered tool to architects and designers working in pre-design and schematic design. It allows you to rapidly set up a site with real-world contextual data and model complex 3D design in just seconds. You can explore a wide variety of concepts and evaluate their performance, their sustainability, and living qualities. So you focus on the outcome. And you can continue the design process with main authoring software like Revit, Rhino, and AutoCAD. Let's review some of the main capabilities. Forma allows you to have a hands-on 3D modeling and contextual data. Architects can start a new BIM project with real-world contextual data. Forma allows you to reduce manual efforts, allowing you to add data like terrain, roads, parcel boundaries. And once the project is set up, you can explore your creativity. Forma automates repetitive tasks with simple and parametric tools. This type of capabilities include tools that are focused on different typologies, the ability to create floor plans, circulation sketches, and parking generators. At the same time, you can draw proposals, multiple proposals at the same time, allowing you to compare trade-off between different design solutions. One of the most powerful features of Forma is the ability to quickly create environmental impact analysis. Forma includes a suite of machine learning-based analysis to reduce trial and error and focus on the project outcomes. This outcome-based design approach allows you to align your sustainability goals early on in the design process. And the open API and our explicit goal of enable connected workflow, it's one of the main Forma features. Architect can sync their work in connection with other main authoring platforms like Revit, and allow you to use both Revit and Forma at the same time. Create analysis validation in Forma and continue detailed design in Revit. And our open API, which is available through the Autodesk APS services, allows users and third-party developers like Simon to enable high-value customizations for very specific user needs. These extensions are available via the Forma marketplace, and later on, Simon will go over how that works with FenestraPro. All right, the next one. If you could help me, Simon.
Sure.
All right, this is a quick overview of the capabilities, Forma capabilities. You don't mind playing the video?
Oh, sorry.
Oh,
try that again. Oh, there we go.
Thank you. So imagine starting a new project with Autodesk Forma, and you create a new site that is very straightforward. It's just a few clicks. Once your site is initiated, you can order contextual data such as topography, roads, 3D context, making sure that you have all your environment data at your fingertips. Then you can get a 3D terrain of your site. This allows you to visualize and interact with landscape, making informed decisions. You can place your referential data, bring 3D files, OBJs that integrates with the model. You can sketch buildings with detailed floor plans, configure different type of house typologies, use the 3D sketch to mold your ideas, and create generative concepts, explore design possibilities. Forma supports your creative process every step on the way. When your concept is ready, you can send your projects into other authoring tools like Revit or additional design development exploration. You can sketch your floor plans, send conceptual layout of your buildings, and add essential elements in the environment like parking, program data, and making sure that the programmatic requirements are met. Within Forma, you can label your elements, making sure that the project has clarity in the organization. And then lately, one of the latest features we introduced is the Forma board, which is like a infinite whiteboard that collects the aggregate thought process of design collaboration and communication between stakeholders. You can compare different design analysis, perform real-time rapid analysis, make quick informed decisions, SORA analysis, win analysis, win comfort index. We have made a lot of improvement in our noise analysis capabilities. And lately, we introduced carbon analysis and continue developing more of these tools that help you inform your design decisions as they occur. You can enhance the capability with custom automations, and we partner with companies like Simon's to create robust third-party add-ons. Next one, please. So that's in a nutshell what Forma is. Forma reduces manual and repetitive tasks, allowing you to get more free time, improves the overall design quality, and helps you integrate more easily with stakeholders in planning and pre-design workflows. Next one, please. With Forma targeting the early stage design, we're making the bridge into make connections with a full end-to-end solutions portfolio. And beyond Revit, we are unlocking data connectivity. That's a big part of our design tool principles, and connect with a vast array of the ecosystem of Autodesk products. The last couple of slides. Next one, please. Right now, Forma is available globally, and there are different options of accessing the tool as a standalone service, as part of your enterprise plan, or as part of the AEC collection. There's also a free 30-day trial if you want to play with it. Go to our website and start playing with it. And if somebody in the last slide, please. If you are interested in developing extensions or plugins that extend the power of Forma to very specific needs, you can access the Forma API developer guides. There's a QR code that connects you there. And with that said, I'll hand this over to you, Simon.
Thanks, Cesar. Yeah, that was really good and really interesting. I think, like, you know, a key part of what you were talking about is some of the benefits, and, you know, like that 3D modeling capability, the real-time analysis, and those connected workflows with other third-party tools like ourselves, but also within Autodesk platforms like Forma and Revit. And that's kind of what I wanted to talk about and kind of pick up on that. Just to give a little bit more context with what we do, FenestraPro, we provide software solutions, I suppose, for facade design, looking specifically at your facade and your envelope, both the geometric design, but also the specification of your envelope components, glazing specifications, etc., to really try and optimize your energy efficiency and reduce that carbon consumption. So we provide a number of tools, you know, relating to what Cesar was talking about. We provide FenestraPro envelope analysis for Forma, which is an extension for Forma. I'll go through now in a second. That allows us to, within that early stage conceptual, you know, environment, let's just say, of Forma, allows us to generate glass to wall ratios, understand the impacts of them, configure that glazing, and distribute it around different orientations or different facades relating to, you know, sun paths or shading from, you know, the surrounding buildings or the urban environment, etc. We're able to select early stage envelope construction types based on a number of parameters and apply those to our Forma model. We can check code compliance in any particular region that you're in, a particular country or state, for example. We can identify what codes are relevant, and we can start reviewing thermal heat gain and daylighting performance and see how that relates to your code compliance. And a big part of what we're doing, which I wanted to kind of talk about today, is the integration with Revit and applying detail families in the Revit environment that, you know, that directly syncs with the, you know, early stage decisions you've made in Forma. And I'll walk through that workflow in a minute, because then FenestraPro for Revit then is our more detailed analysis tool. I suppose within that Revit, more detailed Revit analysis, we can again generate glazing, whether it be windows or curtain walls, optimally, I suppose, in terms of like how do we manage heat gains and how do we you know, optimize in winter months versus you know, mitigating that there isn't an overheat in summer months, for example, applying shading or different types of glazing, etc. And again, understanding how you are complying or checking or meeting code. Again, we can understand heat loss performances, thermal performances, passive solar heat gains, and daylighting performance. And again, accounting for shading, whether that be from surrounding buildings or shading strategies, shading devices, how all of those things are going to impact those different performances that directly relate to your energy performance. And really what we're trying to do is improve that design process, right? Like Cesar talked about a little bit there in the context of Forma, but being able to make decisions quickly, iteratively and early, and really understand what those decisions mean to the energy performance of your building. In FenestraPro, we're big believers in what's measurable is manageable, and being able to see this data in real time, whether it's in Forma or in Revit, really helps a designer understand what decisions he or she is making. So the workflow I want to kind of go through very quickly today is this kind of Forma to Revit using FenestraPro workflow. Obviously, there's millions of things, lots and lots of features and benefits, particularly in FenestraPro for Revit. It's a much more complex tool, I suppose. Not going to go through them all today, right? There's plenty online. Please do feel free to reach out to us at any stage. But we're going to stick to this kind of Forma to Revit workflow relating to your envelope. So what we're going to do is I'm going to jump into Forma. We're going to use envelope analysis just to get some, you know, early stage insights into window to wall ratio, into the impact of code, into, you know, construction types. Then we're going to use a piece of functionality that we have called FenestraPro Connect that allows us to send it directly from Forma to Revit and applies detailed families in Revit relating to the decisions you've made around your window to wall ratio or around your construction types. And we'll just have a very quick look at that. And then we'll look at FenestraPro more generally, you know, how it allows you to check and audit, visualize, resolve your energy analytical model in Revit, which improves both your use of FenestraPro, but also things like Insight or Revit systems analysis or energy optimization, etc. So we'll just kind of touch on that very briefly. As I said, not going to dive into it too deep. This is just kind of a very quick overview, right? So as I was talking about the extension marketplace, look, we have a very simple building set in located in Norway, I think, in Oslo, that we want to analyze. You can find FenestraPro along with lots of other extensions in the Autodesk App Store. You just go to your extensions and add an extension, and we'll be here. FenestraPro envelope analysis, as I said, there's as you know, Cesar said, even there's lots of other extensions, and that's growing all the time. So it's literally just a add, and you know, and it lands in your project. Then your extensions are going to be up here. So there's FenestraPro envelope analysis. I'm going to use this staging version, which is our kind of internal version, just because there's been lots of stuff added in the last couple of weeks. And it will basically ask you for a building to analyze. So this is the really simple building that we've started to apply or started to create in this urban environment. For the purposes of the day, just a very simple building, right? Nothing too made, 4 or 5, 6, 4 or 5 stories. Pretty straightforward. But FenestraPro supports all types of buildings, very quick to use on, whether it's big, small, curves, whatever type of building. So as I said, it's going to locate this building is in Oslo, and it will identify 2 codes that we have in our database. I'm not a Norwegian code expert by any means, but Norway TEK 17, residential or non-residential, as the case may be. This probably is an office. At the outset, let's use these code benchmarks, right? So it's going to apply properties to your wall construction, your roof construction, based on the U value required to meet this code, okay? So a U value of 0.22 for your wall, or a U value of 0.18. We're going to change that in a moment. We're going to start looking at the model properties, right? But we'll get to that in a second. We can then start adding a window to wall ratio, right? So just a total for the entire building. Let's say that's 50%. That's going to update some of my calculations. And what you'll see happening is just very quickly, it's going to render, a really simple kind of 50% window to wall ratio onto every surface, every facade of my building. That will then start giving us some metrics. My overall U value, based again on these values, these thermal performances, average heat gains within the space, average daylighting within the space. We can start seeing some areas, glazed area, wall areas, roofs, etc. But then we can also start looking at some values, right? So we'll see some internal heat gains across each facade, of the building, or even looking at by orientation. And we'll also see the percentage shading. So this is a percentage of sunlit hours onto each facade. So obviously in this urban environment, there's quite a lot of shading to some of these kind of, some of these facades across the street and whatever. So there'll be a high level of shading, which of course will impact daylighting, heat gains, etc. So again, what's measurable is manageable. Being able to see that and understand it allows us to make some kind of informed decisions. I do probably want to start looking at individual facades, though. I don't want 50% everywhere, right? So, I can start isolating individual facades and start looking at them, individually. So start looking at the values of this particular facade to whatever it was, east, southeast. January, my heat gains are this, grown to, a little higher during the summer, and back, quite low again during the winter. Again, my shading, seasonally, I can see it. So again, just very quickly, I can start making decisions, but I can also start manipulating these facades. So let's say these like northeast facades, I may want to say like, well, whatever, for whatever reason, there is 0, percentage shading on these, so I can change each facade as I go, and apply those, and my model will update. It will change then from total 50% to something lower, because remember, I have 50% on loads of facades, but 0% on these 3 facades that I just changed. Okay, so you can get into, as I said, the geometry, and you can even add shading devices as a simple piece of geometry, and FenestraPro will account for that and show the shading and reduce your heat gains and your daylighting. Construction types, as I said, we were using the code benchmarks based on this non-residential Norwegian code, but we may want to model some properties. Okay, so I'll select the model properties, and FenestraPro offers just some really simple construction types. Okay, so again, the Norwegian code says, I can't remember what it was, but the wall construction, I think it was 0.22, something like that. In this case, we have a concrete masonry unit applied to that wall, which is a U value of 0.5. So let's change that and apply, this EIF, exterior insulation. We can change the roof to a built-up roof. We can change the window to triple glazing, etc., etc. And we can apply those, and again, just see the impact on code. So now my wall is probably compliant, but my roof is still non-compliant. My windows are compliant, But again, you can see my U values in total has changed, and you can really start just kind of playing around with individual facades. Lots and lots more you can do with that, and you can really start developing this model a little bit further. But I don't want to spend too much time on this. I kind of want to show you this, what we've just added, so we can send this to FenestraPro Connect to apply this information to Revit. So I just hit that, and then I can go straight to Revit and open that up, right? So I've just got a simple kind of, haven't even got opened anything, but if I go to my FenestraPro Connect add-in, it will open that last Revit model, or sorry, Forma model that I was just looking at. Takes a few seconds just to start initializing, importing, adding some of the detail. As we said, we're adding wall systems, roof systems, floors. And I never mentioned, actually, we're also adding the window to wall ratio, or the window geometry, right? So we just had very simple 50% openings. We may want to get a little bit deeper into that and start, manipulating that a little bit more. But FenestraPro is going to add this as Revit, detailed Revit geometry. So it does this kind of little import and little process that it starts adding all this. And then when it does, which I'm hoping won't take too much longer, because these things always take longer when you're trying to talk over them. We can see a model come in with the appropriate levels, with the appropriate detail. So we're just about there, and you can see it's probably a little bit scrappy just in terms of maybe some of the levels are over here, but we can select my roof, and we can see that. We can see that it is a built-up, sorry, I have two screens, it's open up here. We can see that it is a built-up roof system with a U value of 0.25 and a thickness of 350. We can look at our wall systems, which you'll see there's a lot of glazing that has been applied, and it is a triple glazed unit, as we said. Or this wall system is an insulated external insulation system. So it's 225 mil thick. It's a U value of 0.2. So it directly relates to the information that you have applied from Forma, right? I will probably just jump to this in a kind of here's one, we made earlier. I like to have these kind of analytical surfaces and spaces set up that we can start using FenestraPro. This might take a few seconds. I'm on my home broadband, but oh no, we're good. Right, so we can then start. I'm going to actually start. I did this earlier, and it will remember some of this from earlier. So I won't need to go through all this process that I'm about to go through now. But if I'm opening this for the first time, as I said, we've had issues with the energy analytical model in the past. Dan knows well some of the stuff we've been doing at FenestraPro around the EAM. We work closely with Autodesk around them. But one of the things we have done with FenestraPro in the past while is start allowing a user or a designer to understand what their energy analytical model looks like and what is included in it, right? So we can start generating FenestraPro, or generating an EAM as part of the FenestraPro onboarding process, right? So here's my model. I can start checking that model. So I can start looking at analytical spaces, analytical surfaces within the model itself, and I can start seeing, well, are all my analytical surfaces there? What values do they have? Do they have, are my external walls there? Are my internal walls there? My roofs, my floors, etc. So I can really just make sure that I have a robust EAM. In this case, I kind of do, because I just brought it from Forma. It's a pretty simple model. It's working really well. And then likewise, our codes, right? So what we're using this Tech 17 non-residential. We're going to use that and apply the codes that I want to use for that location, as we did earlier. I'm going to turn off the shading calculation because it just takes a few seconds more. But then what we're doing in FenestraPro is we're generating those solar loads, right? We're calculating the shading, or we're calculating the surrounding buildings, or the visible sky angle, etc., vertical sky angle, etc., to calculate daylighting. So whereas Forma is very iterative, very high level, quick 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 data, I suppose Revit is, we're getting into the weeds a little bit more, and we've much more detail around what we're doing. Okay, so just to give you a little whirlwind tour, and I do want to hand over to Dan now in a second, we can navigate across different facades and surfaces. We can, even select them here, and start, applying different glazing types, or starting to apply different geometry. I'll do it very quickly. I'll just select these kind of 3 or 4 surfaces of this particular facade that we left blank earlier on. I'm going to add some windows to that. Let's just say it's a 2-meter wide window. It's a 2-meter high window. And I know our friends in the US are probably wondering what I'm talking about here. But if this is in the United States, or, a imperial model, you will see imperial values. And we're going to say I want I don't know, 25% window to wall ratio. We want to use, let's say, a solar ban triple glazed unit. So we can search for a solar ban, and we can reduce the U value that I'm looking for to, to really filter down. Here's a good, actually, I'll go a little bit further. There is, say this one, here's like a good, I think it was a vacuum insulated glass, a VacuumMax unit, so we can apply that. So let's just preview the glazing. We'll see those windows previewed, can create those windows, and it just goes through a very quick process, and it will update my model. I think I'll just pull this off to the other screen. It should just write directly to my, my Revit model, then all my windows accordingly, and then I'll just refresh that. I'm not going to do this. This is going to just take a second or two, and that will update the energy model and give me some of those values. Of course, then we can just go to the outputs and create a chart, some graphs, some data accordingly that we can export and download and do whatever we want with it. And that'll take, really quick. That'll go through that same process of just recalculating, and we've got some pretty cool info there. So hopefully that gives you a high level. Just to finish out before handing over to Dan, as I said, FenestraPro envelope analysis is available for free in the Autodesk App Store. You just go to, add extension, envelope analysis will be there. You add it to your project, and that's it, job done. And then FenestraPro for Revit is, there's free trials available. Go to our website, fenestrapro.com. You'll find a free trial, or scan the QR code. Just as part of this webinar, we are offering some free training as well. So please do, we'll see your free trial request come in. We'll reach out. We can give you a 1-hour training session just to get you going, or to allow you to understand a little bit better what's going on with FenestraPro. And, hopefully between Forma and FenestraPro for Revit, you might get some use out of it. Hopefully that gives you a good overview. Dan, do you want to pick up from here?
Sure. So Simon, I accidentally turned off my video and can't turn it back on. We could just go with it as is, unless you want to do that.
Sure. I'll make you the host, because then you can, should be able to push on the slides yourself.
Yep. Sounds good. Thank you. But you'll have to share your screen, because I don't have the slide deck open.
Oh yeah. Oh no, I can't. Sorry, teething problems here. Just make me the, sorry guys, make me the host now. Yeah. So
we're all good. So yeah, I'll just start out by saying we've been using Autodesk Forma for a while now. We use it in lots of applications. We have an urban planning studio that uses it. I teach it at university. I'll get to answering Tony's great question. It is a cloud-based standalone tool, just kind of so you know, and it has the capabilities of doing some really interesting analysis that were previously a fair bit more complicated. We've used tools like Rhino and Grasshopper, which we still do, and have taken the opportunity to compare some of the results. Real quick kind of lead into talking about Autodesk Forma and then FenestraPro. At Lake Flato, we have a design performance action plan, which guides, a lot of principles in terms of how we develop and deliver projects and based on practice, people, and planet. Right. There we go. Little delay there in the arrows. So we have this methodology that we apply to most projects. That above this line is internal project specific workflows. We try to do analysis early and often in a project. So like the graph that Caesar showed, we can affect and implement meaningful change early in a project while it's still actually possible. Below this line is client-facing activities where we're meeting with the client and the extended design team early on so that we can all agree. We can, first of all, pick and all agree on the goals and certifications, and then try and all work towards that end throughout the design process. Here's a similar graph showing that idea of critical design decisions being more effective early on in the process. And so one of the projects that we used Autodesk Forma on was related to our own office remodel, where we recently achieved WELL Building Platinum certification. And to get platinum level, we had to earn many points, and a couple of those points were innovation points for outdoor thermal comfort. So this area is actually a garage that or it used to be a parking garage where we deconstructed the roof, and it has kind of a cool circular economy story where we took and used those materials inside the building, work surfaces in our phone rooms and ceiling accents. So one of those things were to look at the temperature modeling outdoors and then what the temperature change is if it's in an extreme situation, which here where I'm based in San Antonio, Texas, it gets quite hot in the month of July. So you can see on the left 103 degrees Fahrenheit temperature. And then when we add these countermeasures, which is what the WELL building standard calls them, we have a canopy and some trees. We can see that we've effectively changed the temperature by 10 degrees. These graphics that you see here from Forma were submitted as part of the report that helped us achieve this. Again, we also compared these same results in our original Rhino plus Grasshopper workflow, both for the outdoor the temperature analysis, the thermal temperature, and then also for the CFD wind analysis. We can measure the existing conditions, see that in some cases it's above the minimum threshold, and then apply countermeasures and then run the analysis again in Forma and get these great graphs. Tony had asked a good question in the chat about he teaches and he uses Forma or can you use Forma in the classroom? And I'm actually giving a presentation on that very topic next week at Autodesk University in San Diego, where I'll be showing how I actually teach Forma in a college program. I teach graduate architecture students at NDSU, and some of the ways in which it can be used, and it is free and accessible to students. Not all of the Autodesk Cloud offerings are free to students, like hosting a model in BIM 360, but this is, and it's a fairly resource intensive thing to do a 30 to 90 minute CFD wind analysis, for example. So it is a great thing that students have access to this. And some of the ways we use this, I'm going to kind of step through here. They're outlined here, but I have some slides to show this. We can look at an existing site and do some analysis on it before we even impose a design solution. So this project in July in Fargo, North Dakota is 85 degrees roughly. We can do a quick existing conditions for the wind. If our design solution is actually creating a wind tunnel or some uncomfortable condition, we want to actually be able to compare before and after, not just our own design solutions and changing it. Here's a proposed building, and the wind analysis that you see showing up here, basically the comfort scale, is an AI-based result. So we can add these little low walls that you see pointed out there, these little artifacts, and in real time see how they're affecting the wind analysis. Again, this AI-generated wind analysis of the existing conditions it automatically will use a local weather a weather file, an EPW. You don't have to pick one, but it's noteworthy that you can upload a custom .epw file, a Energy Plus weather file. So this allows us to start to incorporate things like future weather data. Here's the wind streams, which is really interesting to look at, but the previous comfort scale is probably a little bit more useful. A new thing that we've been using a lot now that it's so readily available is the traffic noise analysis. Forma, when you create the context model, so you pick an area like Caesar showed, and it automatically brings in all the existing buildings. They're not always to the right height, so we have to double check those sometimes, but we can select the center line of a road, and if it's not already there, we can specify the miles per hour. And then another value that's in my experience is never there. We have to enter the average daily traffic number. So how many cars on average go on that road in a day? And then when you run the analysis, first there's an AI version that's doing it in real time. And then you can see the blue button on the right. When you hit the 10-minute analysis, it'll project a heat map onto the ground and the facade of the building in decibels to tell you how much noise is being created. So one of the great things about this entire ecosystem is it's not just a Autodesk tool set. It has the opportunity, as Simon just showed, to integrate tools like FenestraPro. So here's just sort of a busy slide showing a lot of interesting tools within FenestraPro, within Forma. But now I'm going to actually quickly show you a good, better, best scenario. This is where the, doing different design options early in a project where you can still make big, meaningful changes comes into play. So I just picked an arbitrary site in this hot Texas climate that I live in, South Texas, here in San Antonio, downtown. You can see there's some large adjacent buildings. And then I'm going to just iterate through a sort of good, better, best scenario. And in the upper right, we notice that the east orientation has kind of the biggest problem with solar heat gain. So we're going to make some changes to get to the example on the right, but we're going to step through three options, the three buildings in the lower right. Arguably, the good option isn't good to begin with because a full 100% window to wall ratio is just no longer considered a good option. We can, as architects, we have the opportunity to dial in the envelope, the passive strategies, and one of those ways of doing that when we get to the better option is dial back the glazing, so going from 95% to 50%, and then ultimately on the right, that 50%, changing the glazing type and adding shade surface, whether it's a sun shade or a balcony that's doing sun shading. So here's just drilling into the some of the results that you can get out of FenestraPro. I created this sort of L-shaped building, extruded it up 18 stories, 12-foot floor-to-floor height. And you can see if we just look now, the previous graphs were for the all facades averaged. Now we're just dialing in and looking at just the east facade, which had the most problem. And here's the month breakdown. Maybe in the winter in Fargo, North Dakota, where the university is, where it gets minus 40 degrees, which is the same for Fahrenheit and Celsius. Maybe we want more solar heat gain in the winter months, but here in Texas, we definitely want to knock down those reds in the summer months. And so you can see by switching to 50% and doing an analysis, we've got rid of the reds. The average solar heat gain highlighted at the top is 8. And then if we add the shade surfaces, it drops down into 7. And then here's the shade. Simon mentioned this earlier about adjacent buildings, but the shading is also affected by self-shading of your own design shading itself. This east facade is just wide open. There is no self-shading. So the good and the better have no shading. We add those balconies or sun shades And now you can see we have a significant amount of shading that's happening throughout the year. And then here's sort of a final example. Notice on the left, we can create these things called proposals. So the context model stays the same. Well, actually there was a small existing building that maybe needed to be demolished that can still be there in the existing conditions proposal. But I created a code version, which would be what Simon mentioned. You can actually just get a quick snapshot for your project location, which is super helpful, I think, for a firm like Lake Flato is working all over the US, and there's lots of codes that come into play. Just to have a code version of the proposal and see what the minimums are right there in FenestraPro, and then do a good, better, best analysis. And the main thing that's different in the best option is that there's some extra geometry added. And then a final kind of shameless plug, Autodesk I sponsored a series of videos that I created on YouTube about 6 months ago. And they feature another add-in, actually an embodied carbon tool that is sort of a partnership with an architecture firm in San Francisco called EHDD Architects. And they have this standalone tool, sort of like FenestraPro is a standalone option, called Epic. And the database behind Epic is C-Scale, which is a machine learning sort of AI tool based on real world building stock and embodied carbon data. And so in Forma, if you extrude a building and pick these handful of really simple options about the structure and the type of building, you can see the total global warming potential or embodied carbon information for that building as concrete, steel, and mass timber. And that's it for my segment.
That was really great, Dan. Thank you very much. It was really interesting to see your case study using FenestraPro, and on I do worry about like the reaction of building on a parking lot in Texas. I think that'll raise a few eyebrows, right? But it was really good. And listen, just to summarize, I know there's a couple of questions there and a couple have been answered, and there's one or two I do want to get to, which I will now in a second. But just so to summarize, Cesar did a really nice job of walking through Forma and giving us that sort of high level overview of how it can be used at that pre-design stage, that very early stage, to understand and make decisions that can really impact the entire project going forward. And the earlier you make decisions, the easier they are and cheaper, let's be honest, they are to make. So it's really essential that we can start looking at proposals and early stage concepts of projects, that we can start understanding some of the data and analysis around it. And some of that analysis, things like FenestraPro envelope analysis gives you a really good understanding of your facade and your envelope design decisions, both the geometry but also the construction types, the materiality. And now we have that real-time connection with Revit that you can bring things in and start building up a detailed model and analyzing it a little bit deeper. And Dan talked about some of that adoption that firms like Lake Flato are undertaking at the moment. And I think adoption of innovation like things that we are doing is really essential moving forward, just to improve our processes, but also to improve the energy efficiency of the buildings that we design. So at that, I'd like to say thank you. I just want to. There's a couple of questions. If there's more, please do drop them into the chat, or feel free to shout. Tessa, thanks for joining. Good to see you. She was asking which codes are available in FenestraPro. I used to use it in my former office and curious if more jurisdictions have been integrated. The short answer is yes. There's been lots of codes added, and we are always adding more. Two things you can do if you don't see the code that you want to see is reach out to us. We're always happy to add things in, generally for people to see, but also you can, through the FenestraPro data management platform, you can create your own code, particularly in Revit. So if there's a code in Spain or in, you know, Sweden or whatever that might be. You can create that yourself, give it the appropriate name and whatever. But we always like to hear from people, so please do reach out. And Tony's asking, can FenestraPro export to SBM format for Part L compliance? I'm presuming, Tony, that is in an Irish context. We don't export and integrate with SBM as such, but there's lots of ways you can export a lot of the data that you will be using to put into SBM. For example, areas of zones, areas of surfaces, areas of openings, the properties of all those different surfaces, etc. So there's lots and lots of different ways that you can do that as you go. Anything else? Any other questions or anything, Cesar or Dan, you want to finish up with just before we tie up tonight?
I just want to mention that, you know, the engagement that both you know, Simon, ourselves have with as software developers with the audience is very important. And like Dan mentioned, you know, the analytical analysis on embodied carbon was the result of our partnership with customers and with practitioners like Dan and in the industry. And I'm hearing from Simon as well, you know, his openness to collaborate with customers in advancing the tool. It's also part of the way software is developed nowadays. And so this bridge to connect with customers and adopt what they're think is important, and the tools is a really important part of how we develop our tools. And whenever if you have ways, a suggestion on how to advance both Forma and FenestraPro, we are all ears. Reach out to us via LinkedIn, and we'd like to work with you as well.
Yeah, here. So I guess at that, it's just coming up to the top of the hour. So I want to thank Cesar and Dan for joining and giving a really great presentation on their part. Thanks, guys.
Yeah, thanks for having us.
We're all off to see each other in San Diego at Autodesk University. So I'll see you in real time see you in 3D next week, guys. And I want to thank everyone for joining. As Cesar said, we always are delighted to hear from people. Please do reach out if you have comments, queries, you know, suggestions, anything like that. We'd love to hear from you. So at that, thanks everybody, and have a good rest of your day.